For Unit 2, Day 2 notes, this one's on conditional statements. You guys have seen this as if-then statements. So a statement that can be written in if-then form. The symbolic form is known as P implies Q. This little arrow read as if P, then Q. Or you can say P implies Q. Okay. The if P and the then Q, this whole thing is very important to know. So for the blank, which is the hypothesis, is the phrase immediately following the word if. And then the conclusion is a phrase that immediately follows the word then. So if you look at example 1, if we look at, it says, what are the hypothesis and the conclusion of the conditional statement? So if an animal is a robin, then the animal is a bird. Okay, well, following the word if, this part here, an animal is a robin, that is your hypothesis. And the part that comes after the then, the animal is a bird, that it would be your conclusion. Okay. These little parts right here really should have been moved over after the then and after the if to just show an animal is a robin and the animal is a bird. Okay. Alright, now for the next part we're going to kind of do what we did in the first video, where we talk about something and then reveal. So in this case, if you go to the PDF file, you will have all of this already filled in, so it might be a little bit easier to copy. So an obtuse angle has a measure greater than 90. So we want to change this sentence to an if-then statement. Okay. So what I came up with was if an angle is obtuse, so I got that from the first part here, then it has a measure greater than 90 degrees. Okay. So I had to read my sentence and figure out what is my if and then what is my then. Okay, the next one. All numbers divisible by 4 are also divisible by 2. So we're saying, like, if this is true, then this is true. Okay? So I came up with if a number is divisible by 4, then it is divisible by 2. Okay? It replying the number. Vertical angles share a vertex. Okay? So if two angles are vertical, so this one you had to really think about this part, then they share a vertex. Okay? Then we have truth value. So this is called a conditional as either true or false. So meaning like a sentence that I give you, if then statement, it could be true or it could be false. Okay? So here it says, if a number is divisible by 3, then it is odd. So I was thinking about certain numbers like 39. That's divisible by 3. But 39 was an odd number. So what about an even number? So yeah, that is true. That is true. Well, not really, it's a decimal. But here, if I give you an even number, it can be divisible by 3. Okay. And you get 12. So I gave you some counter examples. So that's a false if-then statement. Okay. If a number is prime, then its only two factors are 1 and itself. So, sure. That was simple. Okay. Moving on. Alright, so this part here, negation. A negation of a statement has the opposite truth value. And I gave you the symbol here. It's like this little squiggly line. That's how you show it, and it would say not P. Okay, so I wrote that right here for you. Red is not P. Statements that have the same truth value are equivalent statements. So for the next part, this table here, we're going to go to another video, which should be the last video for this. It will take a little bit to do. So I advise that you write everything down from the PDF file, and then you go back and you watch the video. I'll make it short and sweet, but it is a very big concept to this particular unit, and you will be tested on this chart. So I'd be very wise to write it and then go over it with me. Okay, see you in the next video.